Hey guys, welcome back to iCode. Remember a while back when we talked about sharding, that was splitting data across multiple servers? I mentioned a problem that when one shard goes down, things break. And there I mentioned consistent hashing as the solution. So today we will discuss that problem and the solution in detail. So imagine that you are running a giant library. You have books with IDs, let's say 101, 102, 103 and so on. And you have a row of bookshelves, shelf 0, shelf 1, shelf 2. Now for deciding that which book should be placed where, you do something simple. You decide a formula based on the modulo operator. So book ID modulo number of shelves will give you the shelf in which that particular book should be kept. For example, say ID is 101. So 101 mod 3, that is 2. So that book will go in shelf 2. 102 mod 3, shelf 0. 103 mod 3, shelf 1. And so on and so forth. That is how you decide. So this works fine until the day when you decide to add a new shelf. Because now the number of shelves changed to 4. So the formula will now become book ID modulo 4. And then suddenly almost every book will have to be moved to a new shelf. So for the book having the ID 101, so 101 mod 4 shelf 1, 102 shelf 2, 103 shelf 3, 104 shelf 0 and so on and so forth. And the same problem if one shelf breaks and it is removed. So every shelf assignment changes. Now let's relate this with the sharding. So when we horizontally scale the database, what we call as sharding, and if we keep a modulo based logic for deciding that which key should go to which server, major reshuffling is required whenever a server is added or removed. And this reshuffling, it is expensive and slow. And at times it can even lead to the downtimes. So what's the solution then? Well, there's a clever idea. Instead of arranging the shelves in a straight row, imagine putting them around a big circle. And now we use some hash function. We'll give the book ID to it and it will return us a number. This number will be mapped to a point somewhere on the circle. For example, book ID 101. It is passed to the hash function and it returns the position, say 27 degree. 102, say 190 degree, right? So that way we place all the books on the circle. We'll also do the same for the shelves as well. So this will decide that where should we place the shelves on the circle. Shelf ID will be passed to the same hash function and that way its position will be decided. Now the rule is simple. The book will be placed in the first shelf you get when moving clockwise around the circle. So if shelf 0 is just after the book 101, book 101 goes there. Understand that how it solves our problem. So if a shelf is removed, only the books between that particular shelf and the previous shelf will be moved, not all the books. If a new shelf is added, it will only get the books from its neighbor. Look at this. So only 105 will be moved to the shelf 3 and rest of the library can remain untouched. This concept is called consistent hashing. It basically minimizes the movement of the data when the number of servers changes. Now, it appears that it is amazing, it solves our problem, but there's a catch. What if shells are not evenly spaced? And this can happen because we are getting the shelf position as well from the hash function. So what if we get two shelves which are placed very close to each other? They won't be evenly spaced. One shelf might get overloaded with the books and the others can remain mostly empty. So to fix this, we use virtual shells. The idea here is to put some virtual shells between the actual shells and these virtual ones will map to the actual shells, but because they are placed in between for filling the gaps, they help in balancing the load. So this way the books get distributed more evenly and a specific shelf won't get a giant pile. Through the same way, virtual servers are placed when we consider this approach for the servers. Now here's where it gets even more interesting. So this used to be the most optimized approach until Google used a brilliant concept for even distribution, and that's vendor corput placement. Vendor corput is a sequence which helps in determining that where should we put the next server so that it is evenly spaced. It is being used in Google's ring study algorithm. Even Netflix uses vendor corput in its API gateway Zul's implementation. They used it for reducing connections count, so the use case is different but the concept is same. Now I won't go in the details of vendor corput because it deserves a dedicated video on it. We'll cover it in the next video. But to give you some idea, It is a way of generating points that are evenly spread out across the circle. So it works by taking a number, flipping its digit in the binary, and using that as the position. I know that it's not very clear by what I said. So I promise that I'll bring a video on it very soon. And if you are watching this video after it has been released, here would be the link. Cool. So that was about the theory. Let's look at a quick demo for the consistent hashing. So I have the demo ready for it, and it will follow our same example of the library. So first I'm being asked for selecting the approach, that whether I want to go with the modulo sharding or the consistent hashing one. So let's select the modulo sharding so that we can see the difference later when we select the consistent hashing. And it is asking me the number of books. Let me select, say 30 books are there, and the number of shards, the number of shells in which I want to split them is, say 2. So it generated some random book IDs, and with this hash formula, which is FNV style hash, it split them in the 2 shards. So this particular book 282 goes to shard 2, 159 to shard 1, and so on and so forth. Now it is asking me to add a new shard. So I'll select 1. Okay. Now there are 3 shards, and the reshuffling happened. The books were moved to the new shard, and the number of books which were moved because of the addition of the 3rd shard, so that the count is 23, which is around 76.6%. So when we use modulo based approach, this is the percentage of the reshuffling that happened. Okay, now let's use the same set of books, the same example. Let's continue it and try distributing using the consistent hashing method. So let's go with the consistent hashing here, and it is asking me the initial number of shards, which would be 2. Okay, now that it has been divided, let me add another shard to that. Okay, now we have 3 shards, and the reshuffling again happened, and you see here that only 14 books out of 30 were moved. That brings it down to 46.6%, which was close to 76% in case of the modulo sharding. So that shows that how consistent hashing is more efficient and optimized. And this was a trivial example, but in the real world situations, in real world problems, this becomes even more efficient and optimized. Okay, so as a quick summary of what we discussed, consistent hashing solves the reshuffling problem from normal modulo sharding. The virtual servers help with the load distribution, and the vendor Corput makes those virtual servers evenly spaced. Now in the next video, we'll see vendor Corput, how it works, why it is so elegant, and how companies like Google and Netflix use it in the real system. If you like the explanation, please give a thumbs up, share it with your friends, and consider subscribing so that you don't miss the next video on vendor Corput. See you in the next one. Till then, keep learning, keep building.